The Rock Whisperer. Do you hear the earth talking to you?
Geology, Rocks and Minerals. 3-1, Mineral Properties. So in this unit, we're going to talk about different properties of rocks and minerals and how we're going to go about being able to identify rocks and minerals. So in this particular video, we're going to be talking just about minerals and the characteristics of minerals. So to be a mineral, you need to be one of four distinct things. One, you need to be natural. So that means you need to be found in nature or you're occurring naturally. Another property is you need to be inorganic, which means you're not made of living things. So coal would not be a mineral because it's made up of past living material. You need to be crystalline. You need to have a structure. So that's the atomic structure, and that structure needs to be an organized structure. So there's repeating geometric patterns like this crystal down here. And the last property that you need to have is you need to be solid, which means you have a definite shape and a definite volume. So as you've learned back in middle school science, you've learned a lot about the different elements on the periodic table. And those elements are going to be the building blocks of all the minerals that we're going to talk about. A lot of these minerals are listed on page 16 in your science reference table, which is the mineral identification section. There are over 2,400 different minerals that are known to man, but only about 12 of them, those 12 make up over 90% of the Earth's crust. So mineral properties. So we're going to talk about how a mineral breaks. And a mineral can break either by cleavage or by fracture. So cleavage are smooth, flat surfaces, and fracture are rough surfaces. So there's a diagram here on the bottom that shows when we talk about cleavage planes and how things break, they can break in a variety of different shapes. So here are four that are shown down here. This is obsidian, which is showing conchoidal fracture, which this looks like kind of like a clamshell shape. The hardness of a mineral, which is the ability of a mineral to resist being scratched. And that's going to be based on the internal atomic structure of the mineral. And in our next video, we'll be talking about the Mohs hardness scale. And that's a scale that we will use to be able to identify how hard or how soft a mineral is, or in reality, its ability to resist being scratched by other minerals or other substances. The density of a mineral, what you primarily need to know is whether it has a high density or if it has a low density. And again, we go back to our first unit and we talked about density. If we know the mass and volume, we'll be able to figure out the density of a mineral. And one other property that we can talk about is color. Usually, color is not a helpful property, but it can be helpful for some minerals, such as sulfur, which is a bright yellow. But many other minerals are black, white, gray in color, and that would not be a helpful property. Another property that we'll be talking about is the streak of a mineral, which is the powder that's left behind. And in the picture right here, it shows you two different porcelain tiles. And these porcelain tiles either can be white, or like this one here, it can be black. This mineral, even though it has a pinkish color to it, it left a white streak. This mineral, even though it looks like pyrite, is goldish in color, it leaves more of a black color streak. The importance of having the two different porcelain tiles are white would not show up easily on white, so it'll make it a little bit easier for you. The crystal shape is going to be based on the internal atomic structure of that particular mineral. That goes back also with the hardness, but we can look at different crystal shapes. And in this particular picture here, you can see a variety of different shapes. And here's another figure that shows you some different shapes. And they all have different names. Obviously, a square should be called cubic. And then we have tetragonal for rectangles. And we can continue on with those. Luster of a mineral is how it reflects light. And there's two terms that we use is metallic and non-metallic. One of the things that you should know is we should not use the word shiny to describe. So do not use that word shiny, because a diamond is shiny. It reflects light. But when we say shiny, a lot of people refer to metallic. But diamond, as I just said, can reflect light. A lot of gems reflect light, and they are not metallic looking. They are non-metallic. So be careful when using descriptive words to describe luster. Sometimes minerals have special properties. Sulfur has a funny smell to it. It smells like rotten eggs. Even though we should never taste minerals in the lab, halite or salt has a specific taste. And other minerals can be magnetic, like magnetite. So minerals form from inorganically by the process of crystallization, or forming crystals. So during that process, though, of forming crystals, we can have different things happen. And in the article that we read on the geology.com webpage, it talked about graphite and it talked about diamonds. And those two minerals are both made up of the same element, carbon, but they have distinctly different properties. Diamond, hardest known substance to man. Graphite is used in your pencil as pencil lead. So minerals can form three different ways, and those are going to be the three different types of rocks that we form. So minerals form through crystallization, which are our sedimentary rocks. They can form through cooling magma or lava, which are igneous rocks. And they can form through heat and pressure, which are our metamorphic rocks. So in our next video, we'll be talking a little bit about the Mohs hardness scale, which we mentioned earlier, and giving you a little more description on that.
Don't forget to listen to the earth.